Pythons are squared is a race circle. Pythons are squared is a race circle. Pi is equal to 3.125 and so on, so on, so on, so on, so on. Euler's number, Champer is constant, twin prime constant, quadruple prime constant. The second smallest pi is that number, 2.pn. Fourth smallest pi is that number, pi and Euler's number e equals mc squared equals -1. The square of -1 equals the measure unit, but I squared equals -1. That is the story of song. The square of -3 equals 3i. Square root of I equals the countermeasure unit j. The square of 5i equals 5j. Unknown number values like x and y and j, x, y, and a, alpha and beta and gamma and pi and rho, golden ratio, silver ratio, copper ratio, k. Golden ratio, super golden ratio, super silver ratio, silver ratio, no waste constant, constant for prime quadruplets. E to the power of 5 equals -1. Square of 4 is 2. Square of 16 is 4. Square of 25 is 5. Square of 9 is 3. It is currently 10:11 a.m. as I end this sentence. The radius of a rectangle equals e to the power of 5 pi. It means that a rectangle is technically negative. E to the power of 5 pi is the most beautiful equation. Pi times e cubed makes a heart when put on the math graph. Desmos is a math graph. Use the math graph. 5, 10, 15, 20, 25, 30, 35, 40, 100, 110, 102, 5, 100, 3, 0, 103, 5, 140, 145, 150, 155, 160, 165, 170, 175, 180, 185.5. This can't be right, or is it? Dun 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 dun. Decimals, integers, non-integers. Those are what decimals are. Oh, rationals, nationals, rationals, nationals, unrationals, irrationals, rationals. For example, pi is a rational number. A rational number is a number that has a repeating digit, but transitional numbers is the same. Can be represented the same. Transitional numbers are also taught possible infinities. They're a number that digits go on forever but isn't infinite. For example, pi and your number. For example, a rational number could be 0.11111111, so on and so on. 0.22, 0.33, 0.44, 0.55, 0.66, 0.77, 0.88, 0.99, 0.999, 0.999, 0.99999, 0.9999, 1.11, 2.22, 3.3, 4.44, 5.55, 6.66, 7.77, 8.88, 10,000. Orders of magnitude. 10 to the power of what you need, what you want, what you know, what you know. 10 to the power of any number is the orders of magnitude. For example, 10 to the power of 3 would be 1,000. 10 to the power of 4 would be 10,000. 10 to the power of 5 would be 1,000. 10 to the power of 6 would be 1,000,000. 1,000,000. 1,000,000,000,000. 1,000,000,000,000. 1,000,000,000,000. 1,000,000,000,000. 1 octo-vigentillion. 1 by 13. Doodle beds, on plets. Get the tatsies, get the patatsies. 1,011,000 I punch number. Infinity plus 1, infinite plus, infinite plusian, infinite plusian. Absolute infinity, terminus infinity, never, absolute never, true absolute never, absolute nan, undefined, undefined, find a possible value, impossible value. It just currently 10, 17, to send the sentence. It is Sunday, May 31st. As you can see, numbers are everywhere. And math is everything you are aware of. 1 plus 1 is 2. There are infinite numbers. So an image of me could be a number. But how would we write it on paper? Crayola could be a number. But why can't we just add another Crayola to get Crayola infinity? Whiteboard infinity, catbox infinity. Any number can be infinity. All numbers aren't. Every number is infinite. How come there's infinite decimals in between each number? Does that make every number equal to infinity? Then what would make it infinity? Infinity 0.5. Yeah, what do rely? E to the power of pi times r squared. E equals mc squared. Why is there so many squares? Squaring, cube, line, how do you do? Dotting, the power of 0. Nada square, nada lining, nada square, Negative cube. Tesseracting beyond our comprehension. Tesseracts beyond the tesseracts. No one can observe these. So on tesseracts, we can only observe equal to or less cubes. We can only observe the third dimensionless. But can we observe 3.1? To observe that, we could observe most of it